So we're going to have now 4 companies present. We always present from the one that seems furthest away. So this will be from Israel, Utilis. Second will be Deimos, which is Portuguese. ARGANS will be third. They are UK French. And finally, coming closer to home, Xona Space. Next, please. Again, please use your chat conversation button to start sending your questions. Severine will be looking at those. She's also gotten some questions from the companies. And so when we get into the Q&A, will be the opportunity for you to ask your questions. Also, this is being recorded so that you'll be able to go back and look at it later, and you'll have everybody's, the speaker's contact details as well. Next, please. So here is the lineup, and our first speaker will be Eric Trerotola. I don't know that I can say it right, cried Eric. Sorry about that. Eric happens to be in San Diego, but it's an Israeli company doing some very important work. So Eric, you've got 10 minutes.
All right, 10 minutes. There we go. My name is Eric Trerotola. I'm the sales manager for North America, as Michael just said. And what I'm going to talk to you about is about leak detection, especially leak detection below ground level leaks that represent 60 to 70% of all the leaks that are out there. So some of the current technologies to find leaks, there's listening and acoustic methods. One of the challenges with that is you really have no idea where the leaks are. And so you inevitably have to walk the entire length of your city streets and your entire distribution system. There's another option, which is a reactive approach, where you basically just wait for customers to call. And once they call, then you can go fix the leak. But again, with 60 to 70% of the leaks that don't surface, you're missing a huge opportunity. Many utilities, what they're using are smart networks or district metered areas. Challenge with that is high capital expenditure, takes a lot of time to employ, and it just takes quite a bit of time. So what's wrong with the status quo? Well, you're basically wandering the streets blindly. And with Utilis, what we do is we actually highlight in these little yellow circles the areas that we've detected leaks from space. So that way you can focus, have your traditional boots on the ground, the field, focus on 5 to 10% of the system. So rather than walking, your entire system, which oftentimes can't be done in a single year, and over the course of several years to do it, we can actually do it one scan all at once. Here's one of those little yellow circles that I was showing you before. And so this is a 600 diameter or 300-foot radius circle. And then what we do is we highlight the actual pipes that you have. So now you no longer have to walk up and down all the streets. Again, you're only focusing on 5 to 10% of the total system. How we do this, it's quick. It's really in 4 simple steps. First, we get an image acquisition. We do the analysis. We then deliver the subject or the data, whether it be within Esri or the city management system, or we have our own system. Then with this guidance, traditional field inspection crews go out to pinpoint the leak and then mark it for excavation and later repair. Let's go ahead and talk about a quick case study. This one is actually in Hilton Head, and this was a stubborn leak that actually existed for several years. Some of the contributing factors that kept this leak hidden, the data from the city of where that leak was or where those pipes were was incorrect. In fact, the pipes were about 100 feet away from where they thought they were. So if they ever did go out and see them, they would be looking in the wrong place. Another challenge was it was actually in the middle of a tidal marsh. So how do you find a leak within already a pool of water? That's a difficult thing to do. So therefore, since it was a tidal marsh, it was only partially exposed during low tide. A little bit about the leak itself. Visual inspection showed animal footprints coming from all directions, leading to one location, a blue lagoon. So kind of funny, we always think we're the smartest critters on the planet, yet here are these animals that actually found the local watering hole. Once the crew got on site, they discovered a leak from a 12-inch main that actually was the size of a softball. So here's the actual leak through Google Maps, where we can actually verify how old this leak actually was occurring for. So this is October 2014. We see the plume in 2016. So 2 years. At some point, it could have been subsurface. Then it finally surfaced. So we know for sure by October 2016 this leak occurred. March 2018, January 2019. So we know for at least 3 years this was leaking. The city had estimated it to be at 700 to 1,000 gallons per minute. So this was catastrophic. They estimated it to be $500,000 a year. So conservatively, based off of Google Maps, we know this was a 3-year event. So it cost the city $1.5 million, but we just don't know. There was a 2-year gap, so it could have been a $2 million problem or a $2.5 million problem if it had actually gone for 5 years. So let's talk about the technology that we use. It's synthetic aperture radar, or SAR technology. And what we do is we use a commercial satellite that's in a polar orbit, so north to south, going around the planet. It's basically the opposite of what most people see, like on the Weather Channel, which that's a geosynchronous orbit, where it's just kind of static over one place. Our satellite goes round and round, and some of the advantages of the satellite, it's continuously orbiting the Earth. It can frequently coverage anywhere on the planet, any place within 2 weeks. It goes around and covers it, and when it's done, it just starts it again. Because it's such a large area that we're actually imaging, we can actually do it fairly affordable. So we actually this is a SAR image of the San Francisco Bay Area. It's 800 to 1,400 square miles. So as you can see, oftentimes we can actually fit multiple utilities in there, so they can actually share on the expenses of the actual image itself. As far as how does it work, it's like any other radar or sonar. It emits a signal. It then gets the collection back of the echo. And some of its capabilities, it can operate day or night. It's independent of clouds or weather, so it can see right through them. It penetrates the Earth's surface. That's very important if we're going to be doing the subsurface leak detection. And it can actually go to 6 to 10 feet. It does detect materials and objects, and most importantly for us, it's extremely sensitive to water. But all of this technology has been around since the 1950s. What has really brought this in, made it a valuable technology, is our analytics. We're able to overcome a lot of the limitations that SARs have by just algorithms. The planet Earth is a very noisy and chaotic environment. You've got cell phones, microwaves, Wi-Fi networks, even airport radars make it very difficult for SAR, and it really interferes with the L-band technology. With our technology, we're able to pull a lot of that noise out and give us a clearer picture. Because we're imaging from space, geometry is an issue. Curvature of the planet is an issue. So we're using a side-looking radar. So just imagine trying to depth perception, see something from across the room. It's much harder to do it that way than it would be if you're right overhead. But with the limitations of SAR technology, we have to do a side-looking radar. So we have to bring that in. And then we do live on a 3-dimensional planet. So hills, mountains, even buildings get in the way as well. So all of that, we use our algorithms to make sure that everything is geo-referenced. So when we say there's a leak right here, we're pointing to the right spot. I'm going to talk to you a little bit about master plan. More and more cities are discovering an aging infrastructure. So what are they facing? Well, they've got a limited percentage that can be spent on pipe replacement. So where do you start? You have your whole system that was built, over the years, some, over 100 years old. How do you start fixing it? Pipes are underground, so it's not visible. So there's a lot of lacking information. And the only reliable information you may have is, the age of the pipes, the material, how many service calls if you've been tracking that, but it really leads to a predictive model. So what master plan does is we're able to score the deficiency levels from a scale of 1 to 5 of how bad certain pipes are. And we use this scoring system to distinguish between 3 of the POIs. The POIs were the points of interest, those yellow circles I showed you earlier. So if it's a single POI, in other words, a single leak that we're seeing on one of them, then we score it appropriately. If it's spatial, in other words, if there's multiple leaks in a small area, then we'll score that a bit higher. And the reason for that is if we can get a group of different type of spatial, a group of leaks, it's a lot more cost effective to replace that span versus running around the city going 1Z, 2Z. And then temporal. So when we do multiple scans, we can see the same leak in multiple in the same area. We know that that's definitely a leak and how bad it is. So we score that as well. All of this is weighed per the algorithm, and then we transfer that to the pipeline, which you can see on the right. So now you can actually have an action of where to go. And this is a real indication of leak from a real sensor. It's not a prediction model. So some of the main benefits: wide system scan for condition assessment. It's non-invasive, no equipment's required, no upfront CapEx investment. The entire system can be surveyed a few times a year, as opposed to just a fraction of it. And we focus on the real hidden killer, which is the 60 to 70% of the leaks that never surface, which is just death by 1,000 cuts. What are we looking for? Well, we've already verified 28,000 leaks with over 400 projects in the world, with covering 55 countries, and we're looking to partner with like-minded people to help the world reduce treated water loss. And we have an office here in the United States, the UK, and then our headquarters is in Israel. Thank you very much.
Eric, thank you. That was an excellent presentation, and you came in at 9 minutes and 30 seconds, so you rock. Thanks so much. Okay, from Israel, we're going to go to Portugal and Deimos. I believe Nuno Catarina is going to be presenting.
Hello, everyone.
Good morning, Nuno. We see you.
Good morning. Thank you. So I'm showing the screen, hopefully.
You are.
So my name is Nuno Catarina. I'm head of data systems for Deimos. Now we're talking about, in line with what Eric was just talking to you about applications and use of satellite imagery in Earth observations. So a little bit about Deimos. So Deimos is a company that is now 20 years old. So it started in 2001. We now have 5 locations in Spain, Portugal, UK, Romania, and Italy. I'm based in Lisbon. And we do all the pipeline for satellite space technologies, from platforms, new launch technologies, new satellites, new sensors. We launched a couple of satellites, one in 2009, the other one in 2014. We are now also involved in the Orbex launcher. We're responsible for the guidance, navigation, control system for that. And then we have the data, payload data part, where we do data access, archiving, catalog, ground segments. This is quite a big area for us. And then the downstream applications from that. So applications for different areas such as agriculture, forestry, fisheries, and so on. Within data systems, we are about 50 people. So within my division, we have people in Lisbon, Madrid, and Arwell in the UK. We do all the activities from R&D to products, systems, services, and then operations. And we have 2 main areas of business. So the one is mission data systems, where we do the ground segment infrastructures. So everything that is on ground processing satellite data or sending flight systems data to the satellites. And we have the downstream data systems as well, which we collect under the brand name of Services for EO, where we do the systems for downstream applications, so the applications for thematic areas. We have several clients, mostly in Europe, but also outside, such as institutional clients, the European Space Agency, EUMETSAT, and so on. And also Airbus, Thales, OHB, and also the big primes for mission systems. So in Earth observation, this is what I'll be concentrating on. As any other data-driven system, what you do is you first access the data, then you develop methods to process this data and do research on the data. Then you extract results which give you knowledge on a particular use case or situation. Then you take decisions based on that. The colors here mean what I think is the advancement level of each of the 4 steps. So Earth observation is sort of a new area, so it's growing gradually at double digits, but it's not yet a consolidated area. But data information, it exists. That's why it's yellow. It exists. It's not completely accessible or organized, but it's typically not a bottleneck. Methods, there's a lot of research being done in Earth observation, so this is definitely not a bottleneck. Results, there are a lot of applications to specific use cases. There's a lot more to address. But then what I think is the real bottleneck is the connection with the end users, because the technology from the Earth observation, the technology is so vast that many times the end users don't have an idea of what the potential this area can bring. One example, for example, from an application that the European Maritime Space Agency, Maritime Safety Agency started using since a few years ago, is the detection of oil spills. Many tankers wash their tanks offshore. This is actually illegal, and they've started using satellites to detect both with SAR imagery and optical imagery to detect oil spills. You can see here, for example, an oil drift. So this can be detected from space, and the number of oil spills has decreased very, very significantly. So the technology is basically based on optical or SAR images. There are other centers such as SWAT, for example, but most of the commercial applications are based on optical imagery or on SAR imagery. Here you can see a beautiful image of Sentinel-2. This is algae bloom, and you can see there's a tiny ship there. So this is something that you cannot see within situ measurements, because the scale of change of these features is several tens of meters or hundreds of meters. Here you can see a SAR imagery. It also reflects it reflects very well on metal, so that's why you can see a lot of vessels in the ocean. You can use this to detect vessels. So in terms of applications, I'm going to basically show you two areas of applications that we've been working with several partners through the last 10 years. So one is coastal management. So you can extract coastal bathymetry from satellite sediment disturbance, sewage plumes, litter accumulation, algae maps. So you can do this from optical and SAR imagery, and we are also, of course, complementing this with in situ measurements, because these are very important to do validation and to calibrate your systems. For example, we've been developing with a number of partners what we call wavy drifters, which I'm putting here in evidence, because this is methodology or these are drifters which are small buoys, about 10 to 20 centimeters. For you, it's at 4 to 8 inches, I believe. And these are completely closed. They are completely enclosed, and they're low cost, and you can measure a lot of things like currents and so on, temperatures and so on. Then what you do with this information, you provide this information to the users, to port authorities, to municipal or authorities, and you provide it with visualization and analytics capabilities. Here, for example, you can see the evolution of, for a single point, the evolution of current and direction of current. Or you can have the information of sediment displacement and so on. So you can provide this information with the user in a co-design approach with the user, or very closely with the user, so that he gets the information in the way that this user sees it. Another area of application that we've been quite active is on sustainable fisheries and a little bit on aquaculture. So here you can see several quantities at Earth observation that we use from Earth observation. For example, here we have this dark red are likelihood of finding given types of fish, sardines and mackerel, and this is calculated using as proxy the potential fish areas, using as proxy chlorophyll concentration and the seafloor depth, so bathymetry and sea surface temperature. You can conjugate that with fishing paths from AIS data and understand if the ships are in a given area, if it's fishing legally, or if the fish stocks are becoming depleted and so on. You can even understand what type of fishery technique they are using by analyzing the path of the ships. And you can correlate with satellite images for SAR. So this is what you have in the bottom right-hand side. So in general, what we have, don't worry about the small print. Well, in general, what we have is a set of data. We have a set of algorithms, and then the user scenarios or the user cases that we work with the end users. In this case, it's for sustainable fisheries and aquaculture, but this is quite a generic approach. So you have your data that you get as you see fit for the algorithms, and then you try to understand what's the best way of dealing with this data to provide the service to either a public authority or a commercial service. So the approach that we've been following is we've put this under our brand name of services for you, where you have these tools for access to data, catalogs, and so on. You have applications. The applications, there's a huge number of applications, so we've been relying on quite a big network of partnerships, and I invite you to get in touch with us for this. Then you managed to create the workflows, user management, and then visualization and user interfaces, and this is what constitutes for what we call an Earth observation services. So what we're looking for is partnerships, users that can test our systems and provide us feedback and new challenges that we can address with this kind of techniques. So we're quite an experienced team. We have a lot of consolidated technology. I believe this co-design approach is very similar to what we're doing, and we have quite a network of providers where we rely for giving us the technology that we need to address particular issues. You have here our contact email addresses for me, Antonio, and two other people at Deimos. So thank you very much. And this is what I have to talk about. Sorry, all right. My alarm going off.
If we could move directly to ARGANS, please. Thank you, Nuno. Very good presentation.
Thank you.
So again, if I could ask everybody to go on mute and turn off your cameras with the exception of the presenter. Thanks very much. So Craig Jacobs with ARGANS, over to you.
Do you see my screen yet?
It's
yes,
coming
we
up.
do.
It's okay, not in slideshow mode, just to let you know.
I just put it in slide mode. Should be happening now. Thank you very much. So firstly, thank you very much to TMA BlueTech for inviting us to present today. I'm going to present ARGANS. My name is Craig Jacobs. I'm the Director of Business Development for ARGANS, and I'm also responsible for the commercial and communications side of our group of companies, which I'll briefly explain in a moment. So ARGANS is a British SME. We're based in Plymouth, and we also have branches in Sophia Antipolis and Brest in the south of France. We focus on satellite Earth observation and remote sensing applications and services, but we also deal a great deal with satellite data, and we run the Sentinel-2 mission performance centers, and our sister company runs the Sentinel-3 mission performance centers. We deal with big data analytics and also have a coastal civil engineering office. We're part of an international group, which is one of the points of differentiation of ARGANS as an SME. So we're able to punch above our weight because we have common ownership and cross management within the group, but also we share our know-how, knowledge, and IPRs. And this group really combines satellite payload data ground segment management, scientific research, engineering, and also we have within the group a very large data center in Luxembourg called Advisio, which has the full archive of Sentinel-1 and 2 data uniquely accessible at the click of a mouse. Along with the full archive of European Space Agency optical missions, and we also have huge processing capacity, which is at our disposal. Our group employs around 130 people, and we turn over just over 20 million euro last year. This is just a brief map of our offices. So we're primarily European based, but we do have an office in Casablanca in Morocco. We've just opened an office in Bangalore in India, and we have an office in Quebec in Canada. We cover expertise in Earth observation, research and development, software engineering, sensor calibration and validation, quality control, and strategic and sustainable planning. Our products and services mainly cover climate change and environmental monitoring from space, nautical charting and coastal mapping, and we deal with big data management and analysis. Particularly our focus is in the coastal zone, but we do cover other areas, as I'll explain later, and Earth observation products and services are our main deliverable, other than dealing with the data itself. If I go through our satellite data expertise, as I mentioned, we run the Mission 2, Sentinel-2 Mission Performance Center, where we're responsible for calibration, validation, quality control of satellite data. We also have softwares and tools. One of them is Dimitri, which is an intercalibration tool across different medium resolution optical sensors, including things like MERIS and Sentinel-2. And we do big data analytics. We've just been involved in the MERIS fourth reprocessing validation team, in addition to the work we do with SMOS. With regard to processes and scientific applications, we're responsible for the processes of the SMOS mission and manage the expert support laboratories. We also are involved in the climate change initiative, particularly on sea surface salinity, where we're working with the data and combining the data from SMOS, Aquarius and SMAP, reaching back to 2002. A large project we've just completed is a coastal erosion project for ESA. This is a project working with 4 countries, so the UK, Spain, Ireland and Canada, working with the likes of the British Geological Survey, Irish Geological Survey, the Ministry of Environment of Spain and the Quebec government, looking at a 25-year data set over 15 test sites of these 4 nations and covering over 3,000 kilometers of coastline using Landsat, Sentinel-1 and Sentinel-2. We're involved in the Climate Change Impact Ecosystem Resilience Project sponsored by the Canadian Space Agency, where we're developing a waterline process based on SAR on Sentinel-1. And we're one of the pioneers of satellite-derived bathymetry. 2 of our managers worked with the French Navy back 30 years ago when it was first being developed. And from that, one of the unique things that we can offer is International Hydrographic Office compliant nautical charts using satellite-derived bathymetry. Marine litter is a big area we focus on, and there are 3 main components to that. One is future dedicated satellite missions, where we've been involved in a project funded by the European Space Agency looking at a bespoke satellite mission for marine litter. And we also designed and developed a simulator in order to support those future satellite missions. We've done another number of projects, again, a pioneering one, which was very early, looking at the use of Sentinel-2 for detecting marine litter under the GEOINT service, which was part of the Space for Smarter Government program of the UK Space Agency. We, in the Black Sea, are looking at the full tracking of litter from waste dump sites, both legal and illegal, to the resting place of the litter. And we developed a processor under a program sponsored by the European Space Agency in the Mediterranean for detecting marine debris. We're currently working on a project to look at windrows, which are the large flows of marine litter or of debris, which is a proxy for marine litter between different currents in the ocean. And then we do modeling and drift and beaching. So we have a platform called the LitterTep, which is looking at the North Atlantic, the flows of litter from rivers into the ocean. So we're able to hindcast the location the litter came from when we can identify it. And in Corsica, we've identified hotspots for beaching of marine litter using wave modeling. As Severin spoke about earlier, we're also working on submarine groundwater discharges. It's a project we've worked on and off over the last 15 years. It tends to become more or less popular, but clearly with water security being a major issue, particularly for island nations, this is an area, in fact, which the European Space Agency introduced us to TMA BlueTech to start the discussion, which results in us presenting here. We also look at water, air quality and carbon sequestration. So on water quality, we have a project which is developing products called High Sea, which is about water quality, particularly important for aquaculture. Air Fresh is a project looking at urban forests and the impact of urban forests on the quality of air within urban environments and its impact on human health. We're developing this in Marseille and in Florence, but with a view to rolling that out to advise local government on the best species of forests, of trees, to have the greatest impact on removal of CO2 in the urban environment. And we have a project which we're just completing, looking at the monitoring of wetland carbon sequestration and the value of maintaining wetlands in a good condition in order to maximize their carbon capture potential. Our management team consists of François Regis, Martin Lezour, who's our chairman, CEO, and one of our owners. He's ex-French Navy, along with Jean Laporte, who's our managing director. Odile Fanton-Dandon is the founder of Acri-ST and our group of companies, and I'm the director of business development for the company. We support a number of the sustainable goals of the United Nations, development goals of the United Nations, particularly 3, which is health and well-being, 6, which is clean water and sanitation, 11, which is sustainable cities and communities, 13, climate action, 14, life below water, and 15, life on land. And the projects I presented earlier cover most of those. We have a number of customers and partners. They're primarily the national space agencies, mainly in Europe, and also government labs and public institutions, primarily because the work we do is scientific and on an R&D basis up until now, although we also do have commercial customers, and we're planning to roll out those more. What we're looking for is really customers and partners in government, public laboratories, international financial institutions, NGOs and academic institutions. A lot of that is for the development of what we do, but also for the funding of the kind of R&D and scientific research that we do. As I mentioned earlier, moving out to private sector companies, but a key area of our development is ground segments for the new space segment. We've just been involved with the launch of a small satellite called Latmos with the University of Paris, and we are developing the ground segment for that in a new site that we've acquired, which is a derelict satellite receiving site just north of Grasse called the Serga. So we're really looking for any partners in satellite ground segment who need satellite ground segment services or Earth observation to cost effectively and scale intelligence and monitoring for policy making and decision making for climate change and the environment. And here are our contacts. So thank you very much.
Craig, thank you. Excellent. Another excellent presentation, and you came in about 5 seconds under the 10 minutes. So well done, well done. And particular shout out because of the work that ARGANS and another company that I think is online, Marine Tech from southern France, in looking at underwater freshwater springs, not just to find them, but also how to utilize them in a safe and sustainable way. So good luck, good job. So our last speaker will be Xona Space, Brian Chan, and if we could bring up his slides. And Craig, we'll ask you to take off your camera, so we'll leave just one person up. Right. Brian,
right.
Thank you. Over to you.
Sure. Give me 1 second here. All right. Could you guys see that?
Looks great. Go for it, Brian.
Okay, fantastic. Thank you all. So thank you for the invite here. I'm very happy to present at BlueTech. So my name is Brian Chan. I'm the co-founder of Xona Space Systems and providing satellite navigation for the age of autonomy. So at Xona, our mission is to provide global navigation services with all the modern features to enable technology to operate safely in any environment. And the way we're doing that is basically providing the most capable and globally available navigation timing service in the market. And we are based in San Mateo, California, but we have some satellite offices in Vancouver, Canada, as well as London, UK. So I guess why is this a problem, or why are we looking into this? When most people think about satellite navigation, they think about GPS or perhaps maybe Galileo or Beidou these days. GPS is a phenomenal system. It's also free, which is great for most users, but it was architected around user needs of a previous generation. GPS signals are very vulnerable to interference, especially at transportation hubs. Specifically, it's becoming more and more common that GPS gets jammed at shipping ports and airports. Excuse me. And the culprits range from truck drivers with personal jamming devices all the way to state-level actors. These issues are growing, as some of these news articles show. Current accuracy of GPS can't meet modern needs, such as self-driving cars, for example, or other autonomous applications. And the lack of a robust independent backup is a huge vulnerability to transportation systems as well as critical infrastructure. So this is really not a new problem. It's one that people have been trying to solve for quite some time now. But in general, the solutions have all held the same assumptions, that the signal in space, GPS, is fixed and can't be changed, and therefore the best we can do is build better receivers or add some sort of augmentation on the ground. There's been a lot of progress here, certainly, but at the end of the day, they are really all 100% dependent on the same fragile signal, making them largely susceptible to the same vulnerabilities. So what we're doing at Xona is, we're one of the first to look at the problem a little differently, to really solve the problem in space. So the way we do this is basically launching and operating a satellite constellation in low Earth orbit. And it's a first system designed from the ground up to provide centimeter level accuracy with the power and security that modern applications really need to operate safely and at scale. So if you consider the recent cost reductions in access to space, as well as the increase in demand for high performance navigation timing, we really believe that we're at the inflection point where this approach is actually financially viable, and here we are today. So how does this actually work as a business? To step out of the technology, we are building and operating the infrastructure, which includes the satellites. Then we partner with traditional receiver manufacturers who then integrate our capability into their devices. From there, this allows us to provide a service to the end user on a subscription model. And so these are anywhere from commercial to government users. And one thing I will say, similar to GPS, there's really an unlimited amount of customers that we can reach. It's a one-to-many type service that's essentially infinitely scalable in that regard. So there's really a myriad of downstream applications for navigation and timing, as you can see here. Even though we are only 2 years old, we found significant traction in maritime, automotive, and drones sectors. So to talk a little bit about the UN Sustainable Development Goals, I've identified 3 where Xona directly contributes. I think goal 9 and 11 are fairly straightforward here. Industry, innovation, and infrastructure. We are building the infrastructure of the future to support modern technology. Sustainable cities and communities are major, I think, benefactors of what we're trying to provide. And I think goal 13 is a pretty interesting one, climate action. So our navigation signals can also be used in remote sensing applications. So for example, we can monitor Earth's neutral atmosphere, global surface winds, and even global soil moisture using just our network of satellites, and effectively using these satellites to characterize our atmosphere and Earth. So here is a timeline of our technology rollout. So before we have the full constellation of 300 satellites, we understand that we need to provide value along the way. That's something that our investors talk about all the time, as you might imagine. So this summer, we're doing a ground-based test with the Mayflower Autonomous Ship Group in Massachusetts. So this is a pretty interesting ship where it's traveling autonomously from Plymouth, UK, all the way to Plymouth, Massachusetts. Clearly, they need some resilient navigation and timing services, and so this is a great way to demonstrate our technology. In phase 1, we deploy 40 satellites, and what this gets us is one satellite in view over the mid-latitude regions where a vast majority of people live. And this provides a precision timing as well as augmentation service. And so there are quite a lot of timing use cases. So for example, in critical infrastructure, such as telecom and power, these folks, like the cell towers and the power substations, really need to better synchronize their towers and substations in time, just so that they can all work efficiently and effectively together. And we've seen that even in certainly in the United States, there's been some executive orders and regulations coming down on really requiring a backup to GPS and to augment these systems. When we get to phase 3, we'll have global availability of our next generation navigation timing service. And so, yeah, it effectively cover the globe. The service is GPS independent. And just to give you some kind of technical numbers here, the service can provide 10 centimeters of accuracy from the box, so to speak, without augmentation, and can provide 1 nanosecond or better in timing accuracy. So here's a quick timeline of what we've done so far. So again, we were founded in 2019. We filed some patents around that time. Last year, we secured several $1 million in U.S. government contracts and grants, most notably with the National Science Foundation. Earlier this year, we signed satellite and launch contracts for our first 2 demonstration satellites. So that will be happening, launching in Q1 of next year, and then from there, opening things up for space-based demos with our technology partners. And this is around the time that we're also closing our seed funding round and moving into the next step. So we realize this is a very large and ambitious program, but we do believe we have the best team in the world to make that happen. Our founding team is combined with some of the best researchers in low Earth orbit navigation, as well as with fast-moving new space tech professionals coming from places like SpaceX and Blue Origin. And we've since begun filling the gaps with seasoned industry pros, as well as advisors, bringing decades of experience in this domain as well. And so to conclude, really we're looking for, I guess, many things here. One is we're looking for beta testers and technology partners for our service. So, as we put these satellites up, and even before with ground-based demos, if anyone in the audience has an end application that could use secure precision navigation or timing, please reach out. We'd be more than happy to talk about what we could do. Additionally, we're seeking technology partners to scale our manufacturing efforts and expanding our global footprint, especially in Europe and Asia. So, as you might imagine, designing and building and operating all these satellites is no small feat. And we're looking for partners along the way. That's about it. So I guess thank you all for listening in. I've included a white paper here if you'd like to learn more about how our technology works. It's also available online freely. And that's about it. So Michael, I will give the floor back to you.
Thank you, Brian. Really exciting technology. I was introduced to you by Dana Goward, who is one of the people really pushing secure ways of locating and timing, and it kind of shows how when we work together there's so much more that we can do. So good job, very important technology. One of the things we always love about when our companies when they speak is ways for them to hopefully work together. And it's exciting to see that. I'm going to ask one more time if we could have people turn off their video and also their audio. We're going to go now to the Q&A. I see a couple of videos that are on, so rather than call people out, if you could turn off your video as well, because you begin to take space on the main screen. So Severine, I'm going to ask you to come back and begin the Q&A session, and hopefully people have been diligently putting questions into the chat feature. And if we could go until about 7 minutes after 9, and then I'll do a quick wrap up. So Severine, thank you very much again for being with us, and over to you.
Okay, so we already have a couple of questions from the chat. So from Magali Morias to Eric at Utilis, what is the accuracy resolution of satellite images used to detect the leaks? And what was the size of the leak detected? And also, like, how small of a leak can you detect?
Great question. So our resolution with each pixel is about six meters, 18, 19 feet, something like that, and which gives us a radius of our area that we're looking at, 300-foot radius or 600-foot diameter. And as far as the size of leak, we can see it as small as 0.2 gallons per minute. So basically, almost like a dripping leak. That's how small.
Okay, thank you. So another question to, I think, Nuno Deimos from the chat from Davidson Oceanic Consulting. I am curious how many of these detectors are currently in the oceans, and how big are they, and what are they made of?
Hello. I'm struggling to understand the question. What detectors? What is meant by detectors? If it's regarding the wavy drifters, the wavy drifters are buoys that have like 20 centimeters maximum. We have several types of wavy drifters, so they are about 20 seconds. They have the electronics inside, and then they have a resin cover which covers the whole instrument.
Okay, thank you. And now we have a question for Xona from Chris. How will the business model extend to the small user? For example, a service provider operating a small fleet of 10 autonomous vehicles.
Sure. Yeah, thank you for that question. So really, I think the Xona business approach has been designed really for widespread adoption. And so anywhere from all the way from kind of defense, high value asset users all the way down to even ultimately smartphone users, where folks are just using and want, say, better navigation indoors. And so it really depends on kind of what features people are looking for. But I mean, even with the small folks, like a subscription basis for 10 users, it would be kind of a certain dollar per year type of service that we envision. But we certainly understand that there are a lot of use cases that, say, again, smartphones or even IoT type devices that have, don't have the budget to spend on all this kind of stuff. So yeah, we understand the price sensitivity of some of these users.
Okay, I actually have a question on all that. So you were talking about having, for example, data for Earth observation, like soil moisture, winds, or atmospheric data. And so do you think these kind of data would be freely available to the public for science purposes?
Sure. So I guess I can give an example. So with this remote sensing technology, it largely is borrowed from current operational technology. So if you've heard of GPS radio occultation or GNSS reflectometry, it's very similar. So there's been a handful of commercial weather data companies such as Spire or GeoOptics that effectively produce pretty high quality data. And so that's really something that we intend to do as well, where effectively, we are really transmitting the signal. And so anyone that wants to, that is licensed to, can pick that signal up. So whether that's the spires of the world or whether that's, you know, state level government actors, yeah, that's something that's all possible.
Okay, thank you for that. And on the same note, I have a question for ARGANS. So Craig Jacobs. So I know that some of your data are publicly available because I'm actually using the Climate Change Initiative, the sea surface salinity data. But I was also wondering about, you were talking, for example, about like developing a simulator for ocean plastic or other tools like that. Would that be available?
At the moment, that is a project that's just coming to a close, so it's not finally released and concluded with ESA. In general, within our group, we also run a thing called the CTEP, which used to be the Coastal TEP. It's one of the thematic exploitation platforms of ESA, and we're currently looking at deploying many of our projects through that Coastal TEP, but that still would be a bit of time for development.
Okay. Thank you. And another question for you. So about, because I've seen in your presentation you have a lot of partnerships, especially with European companies and a space agency. So how do you see the development of partnerships between your company or European companies in general and American Earth observation companies, or also agencies like NOAA and NASA?
We do have some relationships with them, but the one issue that we face is the way that European space, it tends to be funded via ESA, EUMETSAT, or the European Union. So a lot of the funding is limited to European partners, with only a very small availability for building partnerships outside of that as external services. We have, of course, with Canada, quite good relationship, but that's because it's a member state of the European Space Agency, and we have a company based there. We also note, from a British national point of view, there are Commonwealth programs, so they're programs which support funding, say, between the UK and Canada or other Commonwealth states. But we would certainly welcome any joint approaches between the space agencies of the US and Europe to fund programs which we could be part of and build better relationships with US partners.
Okay, thank you. Question from the chat from Anna to Xona. So can Xona technology be installed in underwater autonomous vehicles?
Yeah, good question. So I will say that, you know, we are broadcasting really RF power down to a signal down to Earth, and so it's kind of similar to GPS. It's really just, it's about 100 or up to even 1,000 times more powerful. That being said, I think in general, RF signals are not very good at penetrating water. That's just more of a physical thing. So I suppose for underwater vehicles, if they do surface, let's say, or even maybe a little bit under the water, I think we certainly could provide some service, but yeah, not really much under that.
Okay, thank you. And actually, I have a question for you. Do you think your data could be used for precise orbit determination for some satellites? Like, I'm thinking about altimetries using partly GPS. Do you think your technology could be useful?
Yeah, if you're referring to space-based like other satellites, I mean, certainly. Yeah, I mean, I think we certainly are designing the system around, say, ground users, just because, you know, that's where most folks live. But yeah, absolutely. I think we've actually been even considering use cases outside of low Earth orbit, even for like lunar or cislunar type applications, and so that's an active area of research. Yeah.
Okay, thank you. Another question from the chat from Chris to any of the panelists. So do you foresee remote sensing soil moisture measurements extending to the real-time application of daily irrigation monitoring and control? So who would like to answer that question?
Yeah, I'd be more than happy to give a crack at it. So in order to do that, you would need a geosynchronous orbit which would mean a much higher orbit. When you're in a polar orbit, we could be much lower, so we have a better resolution. So one, I suppose you could do it with geosynchronous. You wouldn't have quite the resolution. If we do it with a polar orbit, we're only in the area, every 2 weeks. So that would be one limitation to it. And the expense, of course, but.
Can I a quick word on that? There are some experiments on that, some research being done on that. We've been working with UPC, with the University of Catalonia, on downscaling GNSS reflectometry images, not images, but measurements. So you can downscale it with optical images, and you can get to a good resolution of 20 meters. So this is being tried out, and there's there are very good results there. I don't know of commercial applications in that case, but at R&D level, there certainly exist. We ourselves, what we did was we had we followed a different approach. We partnered with a research institute and used a model to and to fit to the in situ data, so that can also be a good approach. The problem with both of these approaches is that commercially it's very difficult to justify.
Thank you. And actually, Nuno, another question for you. Would you consider making your drifters available to provide ground truth to the observations from SWAT when SWAT is going to be launched?
Definitely. I mean, that would be a very, very interesting challenge to do. So definitely, I think that would be a very good fit. We also got into discussions with ESA regarding also validation on their side. I think that's one of the best applications that we can provide support to. Definitely.
A question for Brian at Xona. Are there any particular requirements imposed to the ground receivers or any of the GPS, GNSS receiving systems? Are they going to be compatible with your signals?
Yeah, a wonderful question. So that's so we've been in early chats with a lot of kind of the who's who of GPS receiver manufacturers. I will say there's a couple approaches. So one approach is, so I mentioned, we're transmitting signals. There's going to be actually two different types of signals. One I can say is, let's say GPS-like. So we expect that receivers that can receive GPS now can, with minimal or potentially no modification, receive the Xona signal. So that's quite powerful for us and users that we believe. The second part of it is another signal is transmitted at a different frequency. And so while this would require potentially different antenna and maybe a modification to receivers, that really, from talking to folks, that really is nice from a frequency diversity perspective. So when we talk about GPS being jammed at shipping ports, largely that's because they jam that specific GPS frequency. So it's nice that there's an alternate frequency that let's say is harder to jam or requires more effort to do so.
Okay, thank you for that. So I have a question for ARGANS, Craig Jacobs, and you were talking about detecting SGDs. So how do you detect SGDs in your project?
That's a very good question, and I'm afraid that my technological knowledge of it is quite limited. So I can refer that to my technical colleagues and get an answer to you, but I apologize, I'm not able to answer that.
No, that's okay. Thank you.
Sure.
And a question for Eric at Utilis. Do you have a network of agents in Southern Europe? And if not, are you on the way to establish one?
We do. We do have agents, but we're always looking for more. Absolutely. Yeah, I'd be happy if you can send me some information. Can certainly relay that over to our team in Southern Europe.
Okay. And more of a technical question for you, is household irrigation an issue? If treated water is used in the city and the soil is saturated and the SAR is not accurate enough to distinguish between garden and street?
Yeah, well, we certainly might see that, but usually we don't. And that's because people don't saturate. We're looking for saturated soil, and most people don't, especially here in California, they don't saturate to that level. Irrigation is just enough. So we typically, with our algorithms, skip over that, or as we're going through and picking out the POIs, the points of interest, we'll see these light areas and we'll skip over it. We have had certain areas where, especially like in El Paso or sometimes in Oman, where they might lay down a giant with water trucks and just douse the entire area. We'll definitely pick that up, but we kind of see where it's at and we see there's a construction site and we know and we pull it out. So yeah, great question.
Okay. Another question for you. Have you applied your method to small municipalities with very old plumbing for water supply? And because there are lots of recurrent interruptions in supply in this case? Absolutely.
Using a satellite, we're covering a huge area. So a lot of times there's a certain fixed cost to our application, but if we can pull an archived image, especially for a rural area, we actually have our pricing can be all the way down to a linear mile or kilometer basis. So if we already have the image, that can really save it and make it far more cost effective for rural communities. I know in the US we have 50,000 utilities out there, so most of it is handled by the little guys.
Okay, thank you. So maybe I have questions for any of the panelists actually. So excuse me. What are the challenges for the adoption of Earth observation products and services that you face?
Severine, I'm just going to jump in here and invite all of our speakers to switch on their cameras if you'd like. Then you can all kind of have a conversation with that question. Thanks. Great.
Sure. I'll have a go on to start us off, if that's okay. Basically, our biggest issue with adoption is incumbent ways of doing things, I think, and then trust in what we can see from space. So there is or there has been at times a view that space is, or Earth observation is a silver bullet to solve everything. But we all know, working in the industry, that there are many challenges to it. So as there are more and more satellites flying and we're getting different resolutions and consistency over time, and particularly time series, we're able to deal with the error bars much more effectively. And that is the transition that we need to make from science and R&D with Earth observation to really commercial applications for decision making.
Can I jump in? What I see beyond what Craig says is, I mean, the three successful cases of space applications commercially or institutionally are weather prediction, telecommunications, and positioning, so GPS. And these are very easy to understand. So it's very easy to understand that GPS provides you with a position, and weather satellites provide you with weather predictions. In Earth observation, so with optical SAR satellites, the amount of applications and the areas of applications is huge. So I'd say one of the things is like a focus in the sense. This is very confusing to the users because they don't understand what are the extents and the limits of Earth observation. So this is, I believe, one of the biggest drawbacks. Then the other thing is that in Europe, I think in the US it's the same. This is technology push movement. So basically, the European Commission has put a lot of money. I mean, we ourselves have coordinated more than 20 million euros in projects. But these are all from the technology side. And only very recently is the awareness of the use of the technology, so the transfer to operations being addressed, and this is still where it's lacking a lot of investment and action.
Yeah, to add to that, I think if you kind of look at the long view of satellites and relationship with kind of government versus commercial, I mean, in the 60s, right, like communications was everything was all done with government, and then starting in the 60s and beyond, communications became more commercial, and now it's almost, effectively majority commercial. The same is true for observation, imaging systems, and I think now we're starting to see that with the weather as well, like meteorological type systems, as well as navigation, right? So I think in general that the trend is, in my view, good, that it just more actors and more players are in the space, and I think that can only be just in general a good thing for innovation and adoption.
Thank you. Maybe as you're all here, I have a question. So how do you see yourselves working together, maybe?
I can start. So certainly we already work with Deimos, so we have a good relationship with Deimos on a number of projects. With regard to the other two, with Eric and Brian, I mean, with Eric, we have actually looked at water, but not quite in the same way as you. We've really looked at theft of water from canals for agricultural irrigation. But I think certainly, water and leaks is a big commercial area for development. I'm not sure. We'd have to explore what we could do in terms of looking at it, but certainly in terms of irrigation canals, we've done work on that. And with Brian, I mentioned also there previously, we've done quite a lot of work on what we can do with ships in terms of charting and mapping. And I was just wondering, in our introduction 2 days ago, I mentioned there may be some possibilities of looking at the accuracy of their navigation, and also for marine litter detection and flows, particularly when you start talking about autonomous vehicles and the collection of marine litter.
Yeah.
As Frank said, I mean, we've been working with ACRE and ARGANS for quite some time, both in ground segment and application side, and we have a very good working relationship. With Brian, I'm definitely interested in following what you're doing and keeping in touch, especially for GNSS reflectometry. So you mentioned this technique very briefly. So this is basically a passive radar technique where you use the GPS, or in your case, the positioning satellites as source of radiation, and then you get the reflected radiation on ground. You can use this for soil moisture because it's quite sensitive in the microwave band. You can use it for vegetation assessment, biomass, for water, for ocean roughness. I mean, there's a Cygnus, there's a NASA mission on that, and also for altimetry. One of the targets that we have is tsunami detection with GNSS reflectometry, and there is some work in this area showing that you need about 50 satellites. Maybe with your positioning satellites, you can improve the accuracy a lot. So that would be a big jump. With Eric, I mean, I'd be very interested in discussing possible commercial partnerships. As I said, we have a network around Europe, so I'd be very interested in joining that. And with you, Sandrine, on the SWOT satellite validation, that's definitely one of the targets that we should have.
Yeah, and I guess to add to that, as for Craig, you mentioned a little bit about ground station development, and that's something that certainly we're trying to expand our footprint on as well. So maybe that's something in the future. And yeah, just in general, kind of EO and radio occultation as well as reflectometry. I think maybe potentially all four of you guys. Eric, we don't do SAR yet, unfortunately, but But yeah, again, we're launching our 2 satellites next year, and so really just trying to sign folks up to see what might be possible with all that data. So yeah, this is really good stuff.
Yeah, Brian, your stuff, what you're doing is very, very exciting, and yeah, when you start doing SAR, let us know. Love to be a part of it.
All right, I think that's a very logical spot to bring this to a close. To our 4 presenters, to Severine for both your presentation and then moderating, and I would say special thanks to NASA JPL for really helping us with this. This is a fascinating area. You guys have given some great examples on land, with Eric finding the freshwater leaks from the location technology down to centimeter level. Brian, Nuno and Craig, you guys are a little more developed. You have so many interesting programs that you're doing, and I think it shows the geographic breadth of what's happening. This is really an exciting moment, and I can tell you from running a TMA BlueTech, our companies need your help for communications, for location, for ground truthing. There's just so many things that we can and will do together. So as tens and hundreds of thousands of vessels, I'm not talking about the vessels, cargo vessels plying the ocean, I'm talking about more observation related vessels. It's critical that we be working together. So thank you all very much. Melissa, Tamara, can you bring back the last slide just so we can have I think all their names again? Again, I want to just thank you all. And then I think there's one slide beyond this. So for our upcoming events, May 20th will be Sensors in the Circular Economy. June will be Seaweed in the Circular Economy. And we want to thank our partners, BlueTech Cluster Alliance, who helps us really source a lot of these very innovative companies. Both the French and the Portuguese cluster helped us, for example. European Space Agency introduced us to Craig and ARGANS, so it's a great web. The Brink at the University of San Diego does accelerator work, helps companies kind of surround them with subject matter experts. We're on the industry side, specialization. They help them on a more generic basis. And a special thanks to NASA JPL, as I said, and as well as to, although he couldn't be here, Dr. Jim Green, who is the chief scientist at NASA. This is really a great opportunity for all of us. So thank you very much, and we're going to let you all jump on to the rest of your day. Please get a hold of us if you have any questions, and either tomorrow or Monday at the latest. The video will be up on our TMA BlueTech YouTube channel, and it's usually broken into 2 pieces: the first 15 minutes, and then the hour, in this case, hour and 10 minutes subsequently. So please come back again and see our future webinars. And for today, thank you very much to all of you. You really made it a great success today. Thanks a lot.